Hi everyone. In this video, we're going to talk about sliding window, when to use it, and fixed versus variable size windows. So the sliding window technique is a problem-solving method used for optimizing iterative operations over subarrays. It helps reduce the time complexity by converting nested loops into a single loop. So there's two types. There's the fixed window. So those are problems that involve performing some operation on every subarray of size k within the original array. Okay, so we're going to look at an example in the next slide of a problem that involves this fixed window. And then there's also variable size windows. So those are problems that involve finding the optimal subarray of any length within the original array. Okay, so first let's look at a fixed window sliding problem. Okay, so the fixed sliding window example we're going to look at is the maximum average subarray. So in this problem, we want to find a contiguous subarray whose length is equal to k that has the maximum average value. Okay, so there's an example right below there. So we have an array nums with the values 1, 12, -5, -6, 50, and 3, and k equals 4. So we want to find a subarray of size 4 with the maximum average. Okay, so you can look at it. The first average, it will hold the values 1, 12, -5, and -6. The next subarray of size 4 will hold the values 12, -5, -6, and 50. And then the last subarray of size 4 will have the values -5, -6, 50, and 3. So you can probably imagine that you could solve this brute force pretty easily. Just find the average of those three subarrays and get the average and get the maximum. But this sliding window technique will allow us to do that more efficiently. So let's look at the algorithm, how to do that. Okay, so you're going to use two pointers, L and R, which stands for left and right, and those are going to mark the beginning and the end of the subarray that you're working with. You want to get the sum and the average of the first subarray of size k. Okay? And then to get the average of every subsequent subarray, so this is where the efficiency comes in. This is where this sliding window makes this process more efficient. You're going to subtract the value at the array at index place L. Okay, so the first value in that subarray. You're going to subtract it from the sum, and you're going to move the pointer L over by 1. Okay. Then you're going to move the right pointer over by 1 and add the value there to the sum. Okay, and then you're going to calculate the new average. Okay, because you already have a portion of that subarray already calculated, so don't recalculate it, is the idea. Okay. All right, so then you're going to keep track of the new sum and the maximum average, and you're going to continue until you have the average of each subarray. Okay, so let's take a look at it in more detail at this example. Okay, so k equals 4, here's our array. You're going to get the average of the first subarray marked by the left and the right pointers. Okay, so there's your sum, there's your average. You're going to hold on to the max average at that point. Okay, so that's going to be our max average. Then you're going to get the average of the next window. So again, remember, you don't want to recompute the entire sum. So you're going to take the previous sum and you're going to subtract 1. Okay, so that's where our previous left pointer was. And you're going to add 50. So that's where our right pointer moved. Okay, so you're going to get a new sum. You're going to get a new average. Our average increased, so that's our new maximum average. And then we want to get the average of the final subarray of size k. So you're going to take the previous sum, subtract 12, and add 3. You have a new average. It's 10. It's less than the previous average. So our solution is 12.5. Okay, so that's our fixed window example. Now let's take a look at a variable sliding window example. So in this problem, we want to find the minimal length of a subarray whose sum is greater than or equal to a target. Okay, so in our example here, we have an array called nums, and our target is 7. So we want to find a subarray in there, any subarray of any size, that has a target sum of at least 7. Okay, and then our solution is going to be of those subarrays with the sum of a target greater than or equal to 7, which one has the minimum length. Okay, so here's the algorithm that we're going to use. Again, we're going to have two pointers, L and R, to keep track of the window size. You're going to set the initial window size to 1, okay? And then you're going to repeat. you're going to increase the window size by 1 by moving the right pointer over by 1 until the sum of the values in the windows is greater than or equal to the target. Okay, so once that happens, you're going to store that window size. Okay, so now we want to find the next window that has that target. So you're going to do that by decreasing the window size by 1 by moving your left pointer to the right. Okay, and then you're going to continue that repeat step. And in that process, you're going to find all of the windows that have a target sum greater than or equal to 7. Okay, so let's take a deeper look at this. So here's our array. Our target is 7. You're going to start with the window size of 1. Okay, so your left and your right pointers are going to start at the first element in your list. The sum is 2. We're less than our target, so you're going to increase the window size. Okay, so you do that by moving your right pointer over by 1. Our new sum is 5, so again, we're going to increase our window size. Our sum is 6, so again, we need to increase our window size. So the sum is 8. Okay, so we've found our first window with the sum greater than or equal to the target. So our minimum window size at this point is 4. Okay, so now we want to continue and search for other windows in this array. So we're going to move our left pointer over by 1 and continue. Okay. The sum is 6, so we need to increase the window size, so we do that by moving the right pointer. Our sum is 10, so we found another window that satisfies the criteria. The sum is greater than or equal to the target. The minimum, the window size is still 4, so that's still our minimum window size. Okay, so we're going to continue, find other windows, so we're going to move our left pointer over by 1. Sum is 7, so now we found a new window with our target, and that window size is 3. So our new minimum window size is 3. Okay, so we're going to continue by moving our left pointer over by 1. Our sum is 6, so we have to increase the window size. So we move our right pointer over, our sum is 9. We found our fourth window with the sum greater than or equal to the target. The minimum window size is still 3. Okay, so we're going to move our left pointer over by 1. We do that, the sum is 7. So now we have a new window, and this window size is 2. So that is our minimum window size. Okay, so we have to finish up. We'll move our left pointer over by 1, and we are less than the target. So our minimum window size is 2. Okay, so those are our two examples. So when do we use sliding window? So we can use it when we're looking for running values. So it efficiently calculates moving values like the moving sum or moving average over a stream of data. Adjacent values, when we want to process consecutive elements in an ordered structure. Target identification, find specific values or subarrays meeting a criteria. And optimal sequences, so identifying the longest, shortest, or most optimal sequence or subarray. Okay, so that's it. So go to kmalone.io, look at the problem set for this week, and good luck and have fun.